using the definition. So our function is sine of at. So from the definition we know that Laplace of any function, in this case sine at, is improper integral from this kernel, just e raised to negative st, times the function itself. So this is what we need to evaluate to find the Laplace transform. Okay, this is by definition. Now we got a product of two functions, so we can use integration by parts. uv minus integral dv u v du, or let me manipulate this sine at in terms of exponential functions, so it becomes much easier. We know that ei theta is cosine theta plus I sine theta. E minus I theta is cosine theta minus I sine theta. If I subtract these two, positive, negative, negative, I get 2i sine theta equals this minus this. Divide by 2i, so we get, in fact, from this, sine of angle is 1 over 2i ei theta minus I theta. Okay, instead of subtracting, if we add, then we get cosine theta. So I'm going to apply this for our problem, so the integration becomes much easier. We don't have to use integration by parts. E to the negative st, so this is 1 over 2i e raised to I, that angle, minus e raised to minus I angle at. Okay, 1 over 2i is constant, we can pull all the way outside. In the same way, 0 to infinity we can write as a definite proper 0 to a, and let a go infinity. Okay, this is how we take care of this improper integral. Now I would like to multiply, because we can multiply and this to this. So here e to the negative st times, the first is e to the iat. This integration is in terms of t. So when I multiply, we add the exponent. So e, this one plus this one. But at the same time, I want to factor t out. So that negative is plus, but this is negative out, so minus ia. So yes, minus iat. Okay. So when we combine these two, we get s minus iat. So let's do that here. E raised to minus s minus iat. In the same way, when we multiply, is a negative sign, e raised to minus s plus iat. Okay, so that is just combining exponential terms and dt. Now let's integrate 1 over 2i limit a approaches to infinity, and we know that when we have e raised to alpha t and integrate itself divided by alpha, small u substitution. So this is e minus s minus iat divided by this minus s minus ia is a minus sign, e minus s plus iat divided by minus s plus ia, and from 0 to a. Let's plug in upper limit and lower limit. Remember, this is t equals a, this is t equals, because our variable is t. Here is 1 over 2i limit a approaches to infinity of, let's plug in upper limit, so e to the minus s minus ia, this t is now a, over minus s minus ia, this minus and negative plus. I want to replace t by a, so e raised to minus s plus a over s plus ia. Okay, this is just plugging in t equals a, upper limit minus, let's plug in lower limit, that is t equals 0. Now when we plug in t equals 0, so e to the 0, which is 1. So this is 1 over minus s minus ia, this minus and negative plus, plug in t equals 0, that makes e 0, which is 1 over s plus ia. Okay, now let's take the limit. If s is bigger than ia, this is positive, and I'm going to apply this limit e to the negative x. When x approaches to infinity, this is 0. Okay, so e to the negative infinity, so this is going to go to 0. Same thing here. So 0 over number is 0, so we don't have anything left. So this is 1, let me go a little bit down, or 1 over 2i, this is gone, only minus, okay, here is negative times this, so we need to distribute this negative, so negative and minus, this plus 1 over s minus ia, negative positive, negative 1 over s plus ia. Okay, we need to combine these two fractions, 1 over 2i, common denominator, you multiply these two, s square plus a square, because ia times ia, I square a square, and I square is minus 1, so it's just multiply, and this s plus ia minus s minus ia, but there is a negative sign, so need to distribute, so that is plus, yes, cancel, so 1 over 2i times ia plus ia, 2ia over s square plus a square. Now 2i can be cancelled, so we have a over s square plus a square. Okay, this is Laplace transform of sine at. Final.